Also at Wallops, in the airplane hangar in front of our P3 Airborne Laboratory, is project scientist Michael Stuninger. And coming to us from Denver, Colorado is Chad Naughton. He is a science project manager for the U.S. Antarctic program. We'll go straight to questions. And the first one is for Michael. Michael, what exactly is Operation IceBridge?
Operation IceBridge is a NASA airborne campaign that has been started in 2009 to continue the laser altimetry measurements that have begun with ICESat, which ended in 2009 collecting data. And the follow-up mission, ICESat 2, is currently scheduled for 2016. And between 2009 and 2016, that's a very long gap in data acquisition. So NASA has decided to bridge this gap in data collection by using a instrumented aircraft, and you can see one here in the back behind me. This is the P3 aircraft. To continue collecting elevation measurements over the polar ice sheets and the Arctic and Antarctic sea ice in order to build a very long time series how the polar regions are changing.
Great. Okay, so this is the first time that IceBridge has operated directly from Antarctica. Now, Christy, how is that a benefit to the program?
Hi, George. Thanks for asking the question. We're pretty excited to be going to McMurdo this season. It'll be our first ever IceBridge deployment to McMurdo. And one of the benefits we're going to get from taking our P3 aircraft down and being based on the continent down there is that we're going to collect more science hours of data per flight time. Previously, when we deployed from Punta Arenas, Chile, we lost a lot of our science data collection time flying over the Drake Passage. So we really only had about 4 to 5 hours of science collection. Whereas theoretically in McMurdo, we'll fly 8-hour missions and we can start collecting science data as soon as we take off and when we land.
Okay. Now, Chad, you're with the U.S. Antarctic program, and you're essentially in charge of logistics for this and many other science missions in Antarctica. So what exactly is involved in getting scientists and all of their equipment to such a remote location?
Well, thanks for the question. Yeah, so on a program this size with an aircraft like this coming down to McMurdo Station, it's kind of a unique opportunity. There's a lot of detailed planning that needs to occur. We started planning for this over a year ago, and we'll be down. The plane will be down for about 2 weeks. So there's a lot of resources, limited resources in McMurdo Station in Antarctica, and we have a lot of other groups that need to share those resources. So the biggest challenge is ensuring the time frame and the amount of people that need to be on this project to make it successful. It's one of the biggest challenges for any project coming to Antarctica.
And I'm George Hale. I'm at NASA Goddard. Want to remind everybody, you can ask your questions in the YouTube comments box on the Google Plus page, our Facebook page, or tweet to us using #IceBridge. Now, Michael, can you explain to us what's behind you there in the hangar?
Yeah, here directly behind me you can see the tail of the P3 aircraft. And what's happening this week is the instrument teams and the air crew are all here and installing actually science instruments inside the aircraft, the antenna structures on the outside of the aircraft, and pretty much getting the plane ready to deploy to Antarctica. So once we are done here with the installation, we will test fly the aircraft here in Wallops, collect data with it, make sure that everything works properly, and calibrate the instruments here before we are going down south. And then once all this is done, we will ferry the aircraft down to Christchurch and from there to McMurdo, and then we will start collecting data over the ice sheets and sea ice there.
All right, and our next question comes from Cyril at _CYBA. And this question is for Christy. What scientists work in the IceBridge team, and who will be on board during the flights?
That's a really good question. We have a very comprehensive science team. We also have a team of instrument operators. So when we actually deploy to the field, we bring a lot of instrument engineers and operators. Some of them are scientists, not everybody. We have Michael Stuninger, who's our lead project scientist, so sort of in charge of making sure all the science gets done and helping define our science objectives. On the team that flies with us, though, we have students and engineers who operate radar systems. We have a team here from Wallops who operates the laser altimetry systems. We have a team from California that operates our digital camera systems. We also have people from Columbia University and also USGS that operate, and in Canada that operate our gravimeter and our magnetometers. So we definitely have an extensive, comprehensive team of excellent engineers and scientists in the field who help us collect our data to try and ultimately meet our level 1 science requirements.
All right, and Chad, you've worked in Antarctica for quite a while. A good question we have here is, how do you stay warm at the South Pole?
We have issued gear for external layers that help you withstand the elements. And so you bring down a combination of, depending on where you're from, what works for you. We have a lot of people that come down, live in Alaska, Minnesota, across the top, the highline of the United States, but we also have people that come from Florida or, southern states. So we get a good mix, but we make sure they have the right gear for where they're going specifically. We have 3 stations, so at each station you receive different gear. So most of it's warm. It's intended to, to do that, and so and layering is important. Layering is the key.
Layering is indeed the key. Chad, we have another question. This one from @PollyPete. He wants to see if you would speak more about the logistics involved at McMurdo to support IceBridge, such as airfield ops.
Absolutely, yes. We have typically we operate anywhere from 1 to 3 airfields in McMurdo region. One is typically on the sea ice, which can go out on an annual basis, or it can stick around for a while depending on the environmental conditions that year. Another airfield is what we call Pegasus, and it is actually on the ice shelf, so it's hundreds of feet thick, and that is also a wheeled aircraft airfield. And then some seasons and in past years, we used to run an airfield called Williams Field, and that is for only ski-equipped aircraft, like the military LC-130s. Each airfield has its own unique capabilities as well as planning. The logistics of getting them started and operational is a huge effort. It's a monumental effort, and they've got a pretty good handle on it now, so they can get things going really quickly in the beginning of a season to support aircraft. Oftentimes in the winter you might have medevacs, and they have to get the airfields ready really quickly. So you're talking about organizing a lot of people, a lot of heavy equipment to groom the runways, move snow, put snow back on them. There's a lot that goes into it. And hopefully that answers the question.
Great. Well, thanks a lot, Chad. The next question for Christy, and this comes from Rachel @RP News Junkie. And Rachel wants to know what the most exciting and interesting part of the mission is and what the public should be expecting as a result.
Well, that's a really good question. Let's see. If you ask each person on our team, you might get a different answer for that response. So I'll give my personal perspective of that. I think there's 2 exciting parts of this deployment among many. Probably the first one, which will be a huge milestone, will be watching our NASA P3 aircraft land on the runway the very first day. So that'll be a milestone in NASA history and in our airborne science program. Having planned this mission for a year and a half, having worked with ASC and the National Science Foundation, the Air National Guard, the 109th, just putting together all the facts, the requirements, having see that come to fruition, and that's coming up here just in a couple weeks. I think that will be very exciting because it's establishing a milestone, our first time to start science data collection based out of U.S. Antarctic program, McMurdo Station. So seeing our P3 land, and that's going to measure our starting point for collecting science data directly from the ice. I think also the exciting part of this will be, I think, we're going to prove the technology, prove the capability, And once we start getting into our science data collection, ultimately, in the long run, we're going to be able to collect more science data than on previous fall deployments when we were based out of Chile. So our science team and community is very excited about us being able to reach different parts of Antarctica that we couldn't reach before when we were based out of Punta Arenas. So we're hitting some targets that maybe we didn't hit before. So that's exciting to our science team as well as ultimately, in the long run, again, just getting more data because we're going to be based directly off the continent. So those two, I think, are two of the more exciting milestones that we're going to see here in a couple weeks.
Great, thanks. And once again, this is a NASA Google Plus Hangout kicking off the Operation IceBridge 2013 Antarctic campaign. I'm George Hale at NASA Goddard. And this next question we have for project scientist Michael Stuniger. We have a lot of people on Google Plus who want to volunteer to support a NASA mission in Antarctica. What can we say to them? Is that possible?
It's going to be a challenge, as Chad has said. The resources that are available in McMurdo are very limited and have to be shared between many projects. So we had to keep our group small on purpose in order to not impose a big logistic footprint on the community in McMurdo. So I think you really have to think keeping your size down when you go to places like McMurdo. But we do have other areas like in Greenland where people can actually fly in commercially, where we have hotel space, where we, for example, can accommodate the school teachers and have them join our mission and then report back to the classroom what they experience, the kind of science that we do. So I would say Antarctica is a bit of a challenge in getting just more than the absolutely necessary instrument teams and aircrew down there, but we have certainly other places where we can accommodate people from the outside, like in Kangaroos, like Greenland, for example. But maybe that said, there are many other ways to get involved in NASA science and contribute to NASA science. You don't really have to actually go into the field. You can apply for summer internships and other things. So there are many different ways to get involved with NASA.
Thanks, Michael. We actually have another question for you here from Stephanie at SP Ogburn. And Stephanie wants to know what climate science IceBridge is doing and how the government shutdown affected the field campaign and science.
IceBridge per se is not doing climate science. We are producing the data that is necessary to feed into models how ice sheet potentially can evolve over long time scales. But we are not doing climate science per se. So I think the data that we collect is important for climate scientists to understand how ice sheets change over time. What is driving this change? Is it coming from, let's say, increased or reduced snow accumulation, increased surface melting because of warmer temperatures? And IceBridge is in a unique position to sort out all these kind of different aspects. And the results we produce, they will feed directly into climate models and people who try to understand the whole climate system. We are just dealing with a tiny aspect from the climate system, and those are polar ice sheets and sea ice. If you want to understand the Earth climate and how it changes, you really need to look at the entire planet today and run global models, and that's a far more complex question than what we do with IceBridge. Now, the second part of the question was how the government shutdown impacted IceBridge. It has put our preparations on hold for more than 2 weeks, and added some other headaches that we had to resolve. But most importantly, because NSF had to prepare for turning the Antarctic bases into caretaker status. Our field season has been shortened by about 75%, so that means we will collect considerably less science data than we had planned for. And that's a potentially big issue, because one of the reasons, and has been said before, why we go to McMurdo is because we can reach areas that we haven't been able to reach since 2009. And for example, the ice streams along the Cycle coast in West Antarctica are changing their ice surface velocity. We know this from satellite measurements from space, but we don't know how the volume changes there, the ice surface elevation. And so between 2009 and 2016, we have potentially only one data point, or maybe not even a single data point. And I think that's is a big deal to help interpreting the data that we will observe with ICESat 2 in 2016.
Great, thanks, Michael. Now, Chad Naughton, following up on the shutdown question, in your job as a science project manager for the U.S. Antarctic program, how has it affected your work?
Well, we've been running through, that's a good question. We've been running through a lot of scenarios once October 1 hit, and we realized that things were going to be a little bit different this season. Essentially, we're a pretty good team here, and we have a lot of priorities, so we have to work on identifying scenarios. We went through a lot of motions the first 3 weeks of October, and in the end, we prevailed, and we're all systems go for a lot of the good science that's coming down. And so it seems like annually there's always, I wouldn't say there's always something, but there's always there is always something that pops up that is a challenge for program-wide that affects a lot of the science and a lot of the logistics. And so this, in my perspective, this was a big one, but I think we got through it, and I think a lot of the science that the NSF funds on an annual basis is going to continue. There's a lot of groups that come down, like the LTER, that have been coming down for a long time. NOAA has some operations at South Pole measuring CO2 concentrations that they are no longer going to have a skip year in their data. So there's a lot of priorities out there, and we're able to support a lot of that. So we went through some gyrations, and we figured it all out, and what we're going to do. Some groups got deferred, and a lot of them, like Michael mentioned, maybe a little bit of reduced scope. So it's unfortunate, but it's the climate we're in, and we'll just continue plowing forward and supporting the science the NSF funds.
Great, thanks. And we have a question for IceBridge project manager Christy Hansen. From YouTube, user Gandalf Extreme wants to know how much a mission like IceBridge costs.
Well, that's a tricky question. Depends on what you count in the cost, right? Do you count people's labor, so all the time that is put in on any given workday, like how much of my time have I spent on McMurdo planning? So that could factor in. That could factor into the costs. Then you actually have hardware and cargo, so tangible things like I need to ship 55,000 pounds of cargo from the United States down to McMurdo, so there's a cost associated with that. There's a cost associated with getting all of our bodies, our team, flying down to McMurdo. There's a cost with that. We also have technology upgrades that can factor into the cost. So we had some new upgrades that went with that actually were implemented onto the P3. That's a cost. So without giving you a exact quote, it could be anywhere from a couple $100,000 to maybe a little over $1 million. So that's kind of a range that you could think of when looking at a mission equivalent to ours, getting ready to go to McMurdo. I hope that answers your question.
That was great, thanks. And we have another question from YouTube. This one is a little more sciencey. So for Michael, this one is from Thomas Larson, and he wants to know, when was Antarctica not covered by ice?
That was a very, very long time ago. I think, and I may not have the right numbers in my brain at this point. It was about 35 million years ago or 38 million years ago when the Drake Passage between South America and Antarctica opened, and the Antarctic polar current established and cooled down Antarctica. Then we started seeing getting the first kind of alpine glaciers, and that grew eventually into continental ice sheets some 30 million years ago.
Great, thanks, Michael. Another question for you. You said that ICESat 2 will launch in, I believe you said 2016. What will IceBridge's role be after the satellite launches?
The plan is to have at least 1 year overlap between IceBridge and ICESat 2. This will give us one campaign in the Arctic and one campaign in the Antarctic. And this is absolutely necessary to ensure the continuity and the consistency of the data that we collect. Because we are flying slightly different instruments that measure the ice surface elevation in slightly different ways than a satellite. So we need to make sure that the measurements we are doing are consistent with the measurements that are being done by ICESat 2, and in order to determine this, we need overlap between the two measurements. Beyond that, there is a need for every satellite mission to calibrate and validate the data that a satellite collects. And that typically requires airborne measurements, it requires measurements taken on the ground, and all sorts of other things. And IceBridge will certainly play a role in this calibration and validation phase of ICESat 2.
Okay, everyone. I'd like to welcome you to the NASA Google Hangout, kicking off the Operation IceBridge 2013 Antarctic campaign. I'm George Hale here at NASA Goddard, and we're answering your questions. You can ask a question in the YouTube comments box, on the Google page, on the IceBridge Facebook page, or you can tweet to us using the hashtag IceBridge. So, Michael, you talked a little bit about measuring ice thickness and elevation. Can you talk a little bit more about some of the instruments IceBridge uses?
Yeah, the main purpose is to measure the change in ice surface elevation over time from year to year. And this allows us, of course, to estimate how much ice an ice sheet is gaining or losing, which is important because we want to understand how much ice of this melting ice is contributing to sea level rise in the future. And the way IceBridge is doing this is we fly a laser altimeter in the P3 aircraft that you can see behind me here. And this laser altimeter is kind of sending down laser beams from the aircraft down to the ice surface. And a couple of photons get reflected back to the aircraft and go into a detector or receiver there. And then you can measure pretty much the time it takes from when you kind of were sending out the pulse, how long it takes to get back. And if you know the speed of light in air, you can calculate the distance between the aircraft and the ice surface elevation. And the next step to figure out where your ice surface elevation is actually located in an absolute reference frame is you need to determine exactly where your aircraft is positioned. So we need very precise GPS trajectory from the aircraft, which is a big challenge and also kind of a piece of art to do this. And once we know precisely where the aircraft has been flying at what elevation, and know the range between the aircraft and the ice surface from the laser altimeter measurements, we can pretty much determine the change in the ice surface elevation from year in year within a few centimeters of precision.
Great, thanks, Michael. And we have another question from Stephanie Ogburn at ClimateWire, and she wants to know if, Michael, if you could talk a little bit about the data and how it will be used by climate scientists. I know you mentioned ice sheet models earlier, but could you maybe elaborate on that?
Yeah. So IceBridge is a NASA mission, and that means all our data are publicly available after 6 months after data collection. People can go to the National Snow and Ice Data Center website and download the data for free. And George, you mentioned one of the important pieces of data that we collect that are used by people who determine how or project how ice sheets may change over time are ice sheet modelers. And one of the very critical require is the elevation of the bedrock topography below the ice sheets. So it is critical to having a reliable ice sheet model, really the bedrock structure below the ice sheet in a precise way and with a fairly high resolution, because this is what's essentially driving a lot of the dynamic flow of the ice from the interior to the Arctic Ocean, into the ocean, where it contributes to sea level rise. So in addition to ice surface elevation from laser altimetry, we are collecting many different additional data sets that are used by ice sheet modelers and other scientists for answering important questions, how ice sheets evolve over time and what the parameters are they are responding to when they are changing.
Great, thanks, Michael. Okay, we have another question for Christy. IceBridge, during the Greenland campaign earlier this year, we had a few teachers aboard. Could you talk about what it was like to work with some of those teachers during those campaign flights?
Yeah, that's a really good question, George. This recent year in Greenland was particularly an amazing one, I thought, in terms of having a education and outreach project in the field. We had a teacher from Polar Trek, actually a program from the National Science Foundation. And George Hale, obviously you were involved in helping pick and select this teacher to come into the field. His name was Mark Busing, and to this day I was amazed and impressed with his performance in the field. Not only how he acted in the field, but the products that he built during real-time operations that he shared directly with his classroom, and he reached so many students. So for the public out there who doesn't know what that program is, we bring a teacher in the field with us when we go to Greenland. They fly on some of the flights. They meet with each of our team members to learn about the instruments, how they work. A lot of it is science and math-based, and some of them will actually create lesson plans while they're in the field. They'll get video clips or they'll do math problems. Mark was really good. Almost every night he put out a new lesson plan. So he took everything he learned from our active research in the field and turned it into a lesson plan for his students. And we were able to see the end results of that. Another thing that some of the teachers in the field do, like Mark, would do video blogs. So sort of a career focus, teaching the kids out there today what kind of careers can you have. You don't just have to be at your desk all day. There's all these exciting careers you can do in math, research, science, engineering. More exploration based. So he kind of took little video clips of the flight crew, of our scientists, of me, of Michael, and he actually put those out on a video feed, and all of the students could learn about it and comment on the different job positions. So I felt that he really did an amazing amount of work and sent a lot of really positive messages about how exciting math, engineering, these STEM technologies could be. So both Michael and I were very pleased with his performance and felt that having him in the field was an asset.
Oh, that's great. And it was wonderful working with Mark. He had a lot of great material that he put together on his blog. Christy, we have another question, this one from Twitter, from @PollyPete. And Peter wants to know how many seasons IceBridge will work out of McMurdo, whether it's a one-off thing or a recurring thing.
Yeah, that's a really good question. So we're pretty excited that, it took us about a year and a half to plan this very first deployment we're going to do. But this will not be our only deployment. We plan to at least perform one more deployment in the field. That's at least one more, probably more than that. The challenge is that this time next year, our P3 aircraft that we use is going through some major maintenance. It's going to have new wings put on it. So unfortunately, next year, for this season, we won't be able to be based in McMurdo. But the following year, our plan is to be back down there for the entire season collecting data. So what I can tell you is at least 2 seasons, but it is highly likely that we will pursue more than that. I hope that answers your question.
That was a great answer. Once again, this is a NASA Google Plus Hangout, kicking off the Operation IceBridge 2013 Antarctic campaign. I'm George Hale at NASA Goddard. We're answering your questions. You can send questions to us from the Google Plus page, YouTube comments box, the IceBridge Facebook page, or on Twitter using the hashtag IceBridge. I have another question for Michael from YouTube. This is from Austin Virilli. Austin wants to know, Austin understands that the research is significant to scientific modeling. Why should the public care about the thickness of ice?
Very simple answer, because if the thickness of ice changes, it's going to end up at as water in the ocean, which means it will rise sea level. And if you are in a place like here at the Wallops Flight Facility, that's very close to sea level, they are very concerned about some of their runways being just barely above sea level. And if the sea level continues to rise, you will see more and more flooding together with big storms, tropical depressions, hurricanes. So you will kind of see a lot of damage to property, economic loss, and these are all not good things that we want. So it really, what matters in Antarctica, what happens in Antarctica really matters at the places around the coast worldwide.
Great, thanks, Michael. We have another question from Twitter for Christy. Cyril wants to know how the future for IceBridge missions will look.
I think the future is positive for IceBridge missions, I'm pleased to say. So we have an amazing team, a top-notch team who perform very well. And when I say that, I mean instrument operators in the field, the flight crew, our science team, our logistics teams. We deploy twice a year generally, and actually this year it's 3 times a year. We collect data, and then about 6 months after that, our team processes all their data, and they get all of their data products out. And Michael had talked about that, those data sets being free. And each year we continue to collect data in the field. I think our data sets are known to more and more communities across the world. So we're just now in this exciting phase where we're starting to get a lot of feedback. We're starting to see more and more papers being written for people who've used our IceBridge data sets, which is very exciting. And so right now what I can say is that we expect that IceBridge will continue going till at least 2017, because we see that, the community is very excited about our data sets. We're doing well, as well as using a lot of our data sets to help with ICESat 2 CalVal procedures and stuff that Michael had talked about earlier. So again, at least 2017. I feel positive that maybe there's a chance it could go longer than that, but it's hard to say that right now.
Great, thanks, Christy. And I just want to remind everyone, this is a NASA Google Plus Hangout, kicking off the Operation IceBridge 2013 Antarctic campaign. And I'm George Hale at NASA Goddard. You can ask questions via YouTube in the comments box, on the Google Plus page, through the IceBridge Facebook page, or tweet to us using the hashtag IceBridge. And we have another question from Twitter from Cyril again. And Cyril wants to know, Michael, are there flights planned to go over the South Pole?
We have a plan to go close to South Pole, and the reason for that is, as I mentioned, calibration and validation of ICESat and CRYOSat 2 and ICESat-2 are major parts of our work. And CryoSat-2 has a inflection point where all the orbits come close together, that is at 88 degrees south, and so has ICESat-2. So if we collect data along a circle along 88 degrees south, we can actually collect data over all ICESat-2 and CryoSat that have ever been flown. So this is a tremendous data set for validation and calibration. And we probably have to break this up into multiple flights. So we will be heading on a transit back to McMurdo, closer to South Pole Station, and also collecting data in what we call the polar gap, because south of 86 degree and 88 degree, which are the inflection points of ICESat and CryoSat-2, we don't really have any reliable data about ice surface elevation or anything there.
Thank you, Michael. Our next question comes from Google+. Christy, Jarno wants to know if NASA will allow the plane to be tracked by flightradar24.com. This will be a great for aircraft spotters as well as anyone interested in science.
Yeah, so that's a good question. We definitely are advocates of sharing our flight lines and with the community so people can follow us along in real time. I'm not familiar with that website you gave, but what I can tell you is that our airborne science program, the airborne science program website for NASA, has its own flight tracker. So when we take off and land, we turn on our flight tracker and we can show where we're flying on the airborne science program's website. So you can Google that, look that up, and you can follow us, at least using that program to see where we go. Another kind of exciting thing we do for education and outreach, kind of in addition to showing where we're flying and what flight lines we do, is we will post to our Facebook page where we're going each day, and we'll try and actually post photos that we've taken during the mission. Anything that comes up, we can share that with the community, and you can check that out at the Operation IceBridge Facebook page. As well as we can do real-time chatting while we're flying. It's a pretty basic limited capability, but we can share text with classrooms on the ground who want to get involved and follow us along while we're flying to figure out what we're doing, why are we going where we are. Interpersonal questions as well too, like what does it feel like, how high are you, what do you eat? So we do try to share the whole experience with students on the ground when we're flying. And you can actually talk to George Hale in the future about that if you want a classroom to get involved, to kind of see where we're flying in real time, and having a classroom communicate with us while we're flying. I hope that answers your question.
That's a great answer. Okay, and Chad, following up on something that Christy said earlier, she said that it was a year and a half planning this mission. Could you maybe let us know, in your work with the U.S. Antarctic program, how that fits in with others? Is that less time or more time than other projects take?
Right, so the NSF funds projects. The annual submission for grants at NSF, the solicitation opens up, I think, around May or June. So that's when proposals come in. In this round with NASA, they didn't submit a proposal, so what we do is we incorporated them into our normal round of all the other proposals and fit them in, in the year that they want to go. So we start looking at all projects a minimum of a year in advance. So if a project gets funded or submitted in June, it actually won't get funded until the following, about February time frame is about average. Then they'll plan to go down to Antarctica that following year. So most projects require a year to a year and a half of planning. Now, the question specifically is how IceBridge fits into that. IceBridge is a complicated project with a lot of resources. So it takes a little bit longer because NASA was so organized, and because they've done their deployments before to Greenland and on the peninsula side of Antarctica. They came well prepared, and they knew exactly their requirements and capabilities. So Christy and I have spent the last year and a half figuring out how that fits into our little shoebox of resources. How does that fit into other projects? Some projects are quite simple, in a sense that they don't require a full year of planning. Other projects, we might plan for 3 to 5 years before they even deploy. Maybe there's technological advances that need to be made. Maybe there's testing that needs to happen in similar regions, maybe in Canada. There's all sorts, there's a wide variety. I would say IceBridge is somewhere right in the middle. You know, it's very complicated, it's very complex. But again, because NASA was so organized, that's really helpful to know exactly what you need. And I hope that answers the question.
That's great, thanks, Chad. And going back, NSF stands for National Science Foundation. Our next question comes from YouTube, and this will be for Michael. This user wants to know, who had the original idea for IceBridge?
I don't think there was a single person behind this, and it actually predates my involvement in IceBridge. There was a team of scientists in the cryosphere community and within NASA, including project managers at NASA headquarters, that realized that the end of ICESat 1 was coming in 2009, and they were sitting down and looking into possibilities of continuing the measurements that have been begun by ICESat 1. And so people were looking into various different kinds of airborne campaigns or mini satellites that could be launched on a small budget to collect the data, the kind of data sets that ICESat was collecting. And after several studies and a lot of work in teams and communities, NASA made the decision to launch a airborne science project called IceBridge in 2009 to continue acquisition of data until ICESat 2 will be launched in 2016. And that's exactly what we are doing.
Great, thanks, Michael. We have another question from Twitter, from Damara. Damara wants to know if we collect audio data from aurora and space weather, and I know that IceBridge doesn't collect data like that. But Chad, maybe you can give us a sense of all of the different sorts of scientific experiments going on in Antarctica.
Sure. Specifically, astronomy and astrophysics are popular at South Pole because the atmosphere is clear and there's not a lot of light pollution. So there are a lot of instruments at South Pole to monitor the mesosphere, as well as deep space, as well as the neutrino array that was called IceCube that was built over the last decade, simultaneously with the new South Pole Station. There's a wide variety of science projects that occur on the continent: biology, glaciology, again, astrophysics and astronomy, and then you have people studying paleontology too. There's a lot of fossils in Antarctica that are buried in snow, and on these mountaintops, you've seen some of the graphics going down on the screen there. You can see those little brown mountaintops. Some of the, the continent is exposed, and where it's exposed is very valuable to a lot of scientists to gain invaluable data sets on anything from, like what Michael was talking about earlier, about 38 million years ago, and then we've got ice cores out in the higher depths of the ice on the continent. We're drilling down, getting cores, looking back at the atmosphere for 200, 600,000 years ago to get an understanding of what the continent was like then. There's a wide variety. We have divers looking, that are going down and collecting organisms for scientists. There's a lot of seal and penguin study groups locally around the coast, all over the coast of Antarctica by all different types of international Antarctic programs. So there's a lot of science going on down there, and it's good to be a part of it. Actually love this stuff. So hopefully that answers your question.
That's great. Thanks, Chad. So Cyril on Twitter wants to know, and Michael, you can help with this question, how exactly does ICESat help in our mission?
I think it's probably more the other way around, that IceBridge is helping ICESat and ICESat 2. But in order to answer the science questions that we are interested in how ice sheets are changing over time, we need all sorts of different kinds of measurements. And ICESat is contributing to this. ICESat 2 will be contributing to this, and so does IceBridge. So what we do, in addition to collecting ice surface elevation data. We also collect ice thickness data, snow thickness data over sea ice, skin temperature data, all sorts of measurements, and they all will help to better interpret the signal that we will see in ICESat and ICESat 2. So I think it's just IceBridge is one part of a big puzzle that makes a contribution in a specific field that helps a worldwide community of scientists answering bigger questions about how will the climate change change the behavior of ice sheets and change the world.
Thank you, Michael. Another question for Christy from Peter on Twitter. Peter wants to know how many flights we have planned for the campaign versus how many were originally planned, and what some of our field targets are.
Okay, well, that's a good question, multi-part question. So I think our current number that we have planned is, I think it's about 37 flights this year, between 37 and 41 different planned missions. So typically what we do, just to maintain flexibility in the field, is we plan a lot more missions than we ever intend to fly. So we plan land ice missions, sea ice missions, depending on what science we're looking at. And usually what we do is, to help us with planning in the field, is we take all those missions and we prioritize them. You know, these are the top priority, these are medium, these are low. So we have a nice big book that we can go to the weather office with in the morning, and then we take a look and we think, okay, how's the weather in this region versus that region? If the weather looks bad on the east side, maybe we'll fly on the west side. So we'll pull out missions that reflect targets on the west side of the continent, for example. And then we'll look through our priorities and always try and fly our top priorities. When the government shut down, we didn't actually change or remove any of our flights. We still have the same number of flight opportunities or flight plans that we can fly. It just did actually reduce the number of days that we could fly in the field. So our what we call potential science flight numbers have gone down a little bit, but we're still going to work through the list that we've already come up with and try and get as many as we can off the ground. So, you know, regions that we look at, I talked a little bit at a high level, sea ice. So we'll be looking at the Ross Sea, targets over the Ross Sea, the Ross Ice Shelf. We have some stuff in the Transantarctic Mountain Range. We have targets. So the difference is, I guess, with Punta Arenas is we can't reach some of the targets that we did before because we're working out, you know, some of our new characteristics and capabilities with the P3 aircraft, and, you know, looking at our times with how far we can get from McMurdo, how far we can get with the range of the plane and come back. So things like Pine Island Glacier that we would have gotten using the DC-8 deployment, we won't necessarily get on this deployment. So some of the targets has changed a little bit, but we're still excited about reaching some of the new regions. I hope that answers your question.
Thanks, Christy. That was a good answer. We have another question here from Google Plus, and for Michael. We see the P3 there behind you, and the question is why NASA chose an old prop aircraft instead of a new plane.
I think the P3 has been flying or kind of collecting and flying these kind of missions for NASA for more than 2 decades, and IceBridge is not the only mission that is using the P3 aircraft. In fact, it's there's a high demand on having a capability like a P3 for doing atmospheric sciences, all sorts of experiments. So it has a great load carrying capability. It has a lot of space in the interior, and it has a lot of range. And that makes it an ideal aircraft to fly in places like Greenland, very low over the surface of the ice, specifically at 1,500 feet above the ice sheet. So it's a pretty uniquely suited for the type of work that we are doing in IceBridge in Greenland, and also as well in Antarctica. But beyond that, it's also a great capability to have for airborne chemistry and all sorts of airborne science. So It's an airplane that has been around for more than 20 years at NASA, and before this it was used by the Navy, and the decision has just been made that this is worth keeping, and as Christy has mentioned, replacing the wings next year, putting new wings on the aircraft so that we can keep the airplane for another hopefully 20 years.
Great, thank you, Michael. And a follow-up question on that one from Stephanie Ogburn at Climate Wire, and I think Christy, you can handle this one. When is the P3 arriving in Antarctica? When does it start collecting data, and when does that end?
Yeah, all good questions. Putting the calendar together was always an exciting task to do with changing schedules, trying to coordinate with, when we can get down to McMurdo based on when the sea ice runway would be ready for us, and when does the sea ice runway close, because that's weather and environmental permitting how long that runway can stay open. So we definitely have to work inside a set of unique challenges that help us outline our deployment length and time frame. So right now, the P3 is scheduled to leave Wallops on November 11th and arrive in McMurdo on November 16th. There's a plane flying by overhead right now. You can probably hear it. So November 16th is when it should arrive in McMurdo. The following day, the 17th, is what we call a hard down day. NSF dictates the hard down day in McMurdo. And then the following Monday, which is the 18th, we do our very first what we call a test flight. So we're going to take our P3 up and perform some test objectives because it's a different environment, trying to characterize, understanding the weather, get familiar with the environment around us and some of the flying. So our flight crew will do that, check some things out, and that'll be the 18th. And then the 19th is when we start our first science flight. So the 19th is when we'll get into our first chance to actually collect hardcore science data.
Great, thanks, Christy. I've been told we have a lot of questions, people coming in and asking about the movie The Thing, and I have to say that with IceBridge, one of our favorite movies is Airplane. We like to quote that one a lot. We have just a few minutes left, so is there anything anyone would like to add?
Oh, not from my end.
All right.
It's gonna get noisy here in the hangar.
Oh, great. Chad, other than IceBridge, what missions are coming up in McMurdo?
As far as science groups deploying, there are some concerted efforts from CRESIS, the Center of Remote Sensing, University of Kansas. They're coming down. They had a skip year last year. They come down about every other year, and they're flying some AUVs around as well, gathering a lot of snow and ice data. The Wizard group, which was last year, I don't know if anyone remembers, but they drilled down through Lake Willans, into Lake Willans through about 1,000 meters of ice and recovered some organisms, and they've taken those back to the labs. And I think you can go look at Wizard's webpage, and they have some of their exciting science going on there. They're coming back. They've been reduced in scope a little bit, but they're still meeting some of their priorities and objectives. Those are the two big deep field efforts that are going on. And then there's lots of science groups that come to McMurdo and come to South Pole and come to Palmer Station on the peninsula side that are doing their annual science events. A typical science event is funded for about 3 years. So they'll come down and do a lot of the same science. It's always fun. The SEAL groups that come through McMurdo, they go out and they weigh seals, and they look at, some of them have been tagged for 20+ years, and they put cameras on their heads sometimes, and they'll see the profile of their dives and what they're chasing and fish. So there's a lot of exciting science out there. If you go to www.USAP, and that's United States Antarctic Program.gov, you can see some of the links as well as the NSF's website at nsf.gov if you want to learn a lot more about the science.
Great. Thanks, Chad.
You bet.
So wrapping up here, we'd like to thank our panelists, Christy Hansen, IceBridge Project Manager, Michael Studinger, IceBridge Project Scientist, and Chad Naughton, Science Project Manager for the U.S. Antarctic Program. We'd like to thank everybody for participating in this Hangout and remind you that this Hangout will be archived on YouTube. For more information about IceBridge, you can go to www.nasa.gov/icebridge. And thanks, everybody.
Thank you.
Thank you.